Today we'll be working with lesson 8-2, factoring by using the greatest common factor. In the first example, we have a binomial 2x squared minus 4. To factor out the greatest common factor, we have to look at the factors of each term. Factoring out a polynomial, a binomial, one way to think about it is you are undoing the distributive property. And we say it's in lowest terms when the terms have no factors in common. I've already factored the terms 2x squared and 4. I broke 2x squared apart into its prime factors, 2 and x and x. 4 we know can be factored into 2 times 2. Therefore, the GCF of these two terms is 2. Now remember, we're going to undo the distributive property. We're going to pull that common factor out of each term by dividing each term by 2. 2x squared divided by 2, you're going to pull the 2 out front, is equal to x squared. Minus, we're preserving the minus sign, 4 divided by 2 is 2. We know that this polynomial is completely factored because x squared minus 2 has no factors in common. Example 2. 8x cubed minus 4x squared minus 16x. We'll be doing the same thing in this example, but we are looking at the greatest common factor of 3 of the factors. 8x cubed, 4x squared, and 16x. Breaking apart 8x cubed into its prime factors, we have 2 times 2 times 2 times x times x times x. 4x squared becomes 2 times 2 times x times x, and 16x becomes 2 times 2 times 2 times 2 times x. The greatest common factor, therefore, is the product of the common factors, 2 times 2 times x. We have no other factors in common for all 3 terms. So therefore, the GCF is the product of GCF is the product of 2 times 2 times x, or 4x. This is the number we will pull out front, leaving everything else in parentheses. Our factored polynomial will have 3 terms because we're starting with 3 terms. 4x is our GCF. We're going to divide each of these terms by 4x. 8x cubed divided by 4x. 8 divided by 4 is 2. X cubed divided by x is x squared. Minus 4x squared divided by 4x. 4 divided by 4 is 1. X squared divided by x is x. And finally, 16x divided by 4x is 4. Now, we are preserving the negative signs because we have not divided by a negative number. So we have a minus 4x squared and a minus 16x. After factoring out the 4x, we have minus x and minus 4. Negative 14x minus 12x squared. Now, you can either continue writing out your greatest common factors by looking at the product of the prime factors, or you can think to yourself, the greatest common factor of 12 and 2, excuse me, of 14 and 12 is 2. And the greatest common factor of x squared and x, the largest number or variable I can divide by is x. So the greatest common factor of the 2 terms is 2x. However, if you'll notice, we have a negative and a negative. So instead of dividing by a positive 2x, we're going to pull out or divide by a negative 2x. We're dividing the first term by negative 2x and the second term by negative 2x. That's the number we pull out front. What's left inside is the quotient of negative 14x divided by negative 2x, which will be 7. And negative 12x squared divided by negative 2x is a positive because a negative divided by a negative is a positive 6x. To make sure we've done this correctly, we can distribute. So we're going to check by distributing. Negative 2x times 7 is negative 14x. Negative 2x times 6x is negative 12x squared, and it checks. In the second level of examples, we have a number outside parentheses times a binomial. To determine what the greatest common factor is, remember the number inside parentheses is simply a number. It's another factor. So when we factor the first term is 5 times the quantity x plus 2. We can break that up, we get 5 times x plus 2. So 5 is a factor and x plus 2 is a factor. In the second term, 3x times the quantity x plus 2. When we break that up into factors, we get 3 times x plus 2. The factor in common happens to be a binomial, x plus 2. That's the factor we pull out front. So our factored form becomes x plus 2 times what's left. We have a 5 and we have a 3x. So our factored form is x plus 2 times 5 plus 3x. You can do the same thing with a negative coefficient. Negative 2b times b squared plus 1 plus b squared plus 1. This time, if you'll notice, there is not a number in front of the second binomial. We're going to put a 1 there. We're going to put the ninja 1 there. You should also notice that we have a common factor of b squared plus 1. This is the factor that we're pulling out front. Our factored form is b squared plus 1 times negative 2b plus 1. To check it, we can use FOIL, and we can multiply first. B squared times negative 2b is negative 2b cubed. And we can do outside. B squared times 1 is b squared. Inside, 1 times negative 2b is negative 2b. And then last, we'll do 1 times 1, which is 1. Now, if we were to use the distributive property to multiply each of these terms, we would find we have the same answer. Next, we'll look at factoring by grouping. This is our fourth level of example. Factoring by grouping is a good technique to use when you have 4 terms. When you're told to factor by grouping, you're looking to see if you have the same common factor in the first set of terms as you do in the second. So I broke it up by polynomial into 2 different binomials, 6h to the 4th minus 4h cubed, and 12h minus h. Now we're going to look for common factors between every pair of terms. So I'm going to look at the first two, 6h to the 4th and 4h cubed. The greatest common factor of 6 and 4 is 2. The greatest common factor of h to the 4th and h cubed is h cubed. So I'm going to pull out a factor of h cubed, actually of 2h cubed. So now let's see what's left. 6h to the 4th divided by 2h cubed is 3h. I know that because when I multiply them back together, 2 times 3 is 6, h to the 3rd times h is h to the 4th. Minus 2h cubed divided by, 4h cubed divided by 2h cubed. The h cubes cancel, and I'm left with 2. Now I'm looking at the second pair of terms, 12h and h. I'm going to put a plus sign because I have a plus sign here. The greatest common factor of 12 and 8 is 4. So I'm going to pull a 4 out. 12h divided by 4 is 3h, minus, because I have a minus sign, 8 divided by 4 is 2. Now, when I look at this, I see I have a common factor of 3h minus 2. That's going to go in front. What's left? After I divide the first term by 3h minus 2, I have 2h cubed left plus 4. So this is my factored form. Sometimes you have to factor out the opposite. To do so, you're going to use factoring by grouping. I'm going to call this example C. So I had 4 terms, and I'm putting parentheses around the first 2 and around the last 2. Looking at the first 2 terms, I have 2x cubed and 12x squared. The greatest common factor of 2 and 12 is 2. The greatest common factor of x cubed and x squared is x squared. And I'm going to divide each term by 2x squared. 2x cubed divided by 2x squared is x minus 12x squared divided by 2x. The x squared is canceled. I'm left with a 6. Plus my second set of terms, 18 and 3x, have a common factor of 3. I'm going to pull a 3 out front of the parentheses. 18 divided by 3 is 6, and negative 3x divided by 3 is negative x. Let's take a look at the binomials. I have x minus 6 and 6 minus x. They are opposites, and I want them exactly the same. How can I do so? Well, you can make what's inside parentheses opposite by factoring out a negative. So instead of factoring out a positive 3, I'm going to factor out a negative 3. Right here where I have a plus 3, I'm going to make that minus 3. And 18 divided by negative 3 is negative 6. And negative 3x divided by negative 3 is a positive x. Now, if you'll notice, x minus 6 and negative 6 plus x are the same. So I can write my factored form, which is 2x squared minus 3 times x minus 6. This is how we factor by grouping, and this is how we factor by using our greatest common factor.